So what I did is I picked some problems to help us out, and they're very similar to what you're going to see, okay, or what you've already seen, okay. So how many picoseconds are in 2.80 hours? Okay, now they didn't say hours; they had H here, right? H, it means hours, guys. When you see that, it means hours, okay. So we have 2.80 hours times, okay, so I got to get to picoseconds. But before I can get to picoseconds, I need to get to seconds, all right? And from the conversion that I gave you today, we know that 1 hour is 3,600 seconds, okay? So now the hours cancel here, okay? And I'm left with 2.80 times 3,600, and that would give me the number of seconds. Now, I want to say this. We're starting with the accuracy, and I'm going to talk about this more on Thursday, the accuracy of three places here, right? 2.80. In science, you cannot write 2.8 in lieu of 2.80. It's 2.80. This is a measured value, okay? All right, so we want to go to picoseconds, right? All right, so I know from here, from my conversion that I showed you guys, okay, a picosecond is equal to 1 times 10 to the negative 12 seconds, okay? So you could also, 1 times 10 to the negative 12, if you just wrote 10 to the negative 12, you'd be right, okay? All right, so we're going to multiply this by, okay, we want seconds, and that was 1 times 10 to the negative 12 seconds is 1 picosecond, and that's a lowercase p and a lowercase s. Lowercase p, I mean, that's one of the reasons why I went over all these symbols with you guys, okay? A lowercase p is pico, and the s, lowercase s, is seconds, all right? Okay, so if we go through and multiply this, I'm going to separate this. Any 10 to a power, I'm going to separate out, okay? So this is going to be 2.80 times 3,600. All over 1, which I really wouldn't need to write. And then times, and this isn't 10 to the negative 12th. It'd be 1 over 10 to the negative 12th. Picoseconds. Whoops, I started to write seconds. So this is a picosecond. Okay, so 2.80 times 3,600. I'm going to put that into my calculator. Be careful, I started to type it in wrong, okay? And that's 10,080, okay? So this is equal to 10,080 times, and then we need to know from our math classes that 1 over 10 to the negative 12th really is the same as 10 to the 12th. So that's times 10 to the 12th picoseconds. Okay, we're not done yet for 2 reasons, okay? One reason is that this needs to be a number between 1 and 10, but under 10. It can't be exactly 10. So this needs to be a single digit, so 1.5, 1.0. It needs to be 1.0080, and we need to carry all of these places, okay? So this is 1.0080. Okay, now we could get this back if we multiplied this by 10 to the, and then we count 1, 2, 3, 4, 10 to the 4th. Okay, that's just taking this number and writing it in scientific notation, okay, which you should know how to do, okay, and then times 10 to the 12th picoseconds. Okay, now if we look at this, okay, we have 10 to the 4th times 10 to the 12th. That means exponent rules. We can add our exponents. So this is 1.0080 times 10 to the 16th picoseconds. Now, if you type this into the computer right now, you'd get it wrong, okay? It doesn't mark it wrong. It just won't accept this as an answer because it's not correct to the number of significant, it's called significant figures. Up here, we started with 3 digits. This number right here needs to be 3 digits of precision, okay? So if we look at this 1.00, okay, we would stop here, but we're gonna round this. Since this is 8, this is gonna become a 1, because we're gonna round up, and this becomes 1.01 times 10 to the 16th picoseconds. And notice there's 3 significant, it's called 3 significant figures. This had 3 significant figures. If you type that in, you would get the answer right, okay? I've helped several people on Zoom this afternoon get this right, okay? So that's how you do it. And I apologize for not doing the significant figures. I just didn't think it was gonna be that big a deal in the problems I assigned. I know it's gonna be a big deal in the future, and we'll talk about it on Thursday. I had planned on teaching it to you on Thursday, okay? All right, let's go to the next problem. So here's another problem that's very similar to what you're gonna see. It's just the numbers are different, okay? Now 57.0 is important. That's not 57, that's 57.0 megavolts. So this has 3 digits that are important to us. So our answer will have to have the 3 digits also, okay? So we're gonna start with the 57.0 megavolts. Okay, now the abbreviation for volts is V, okay? And mega is a capital M. Okay, so we have 57.0 capital M capital V for megavolts, okay? Times, okay, so we want to get just volts out of this, right? So because I want megavolts to be on the bottom, because I want the megavolt to cancel, and I want just volts on top, okay? And so from our handy dandy chart here, okay, we know that 1 megavolt is 1 times 10 to the 6th volts, okay? So this would be 1 times 10 to the 6th volts, and that would be 1 megavolt. So our megavolts cancel, and we're left with 57.0 times 1 times 10 to the 6th. So 57.0 times 1 is 57.0 times 10 to the 6th volts. Okay, so now this isn't correct yet, okay? Because this number needs to be between 1 and 10. It can be 1, but it can't be 10, okay? So how can we write this number in scientific notation? So this number could be written as 5.70 times 10 to the 1st power. Because if you multiply 5.70 times 10, you'd get 57.0. And then we still have the times 10 to the 6th volts. Well, 10 to the 1st times 10 to the 6th would be 10 to the 7th. So this would be 5.70 times 10 to the 7th volts. Now, this has 3 digits, right? We started with 3 digits. We can't be any more or any less accurate than what we started with. So that's why this needs to be 3 digits. And I'm gonna talk about this more on Thursday, okay? So let's go to the next one. All right, so the speed of an object is 542 meters per second. What is this in kilometers per hour? All right, so we're gonna start with 542 meters per second. And then we're going to multiply by, okay, we need to get to hours, all right? And I know from the conversion I gave you today, 3,600 seconds, and I'm going to put that on top so my seconds cancel, is equivalent to 1 hour. Okay, so now what I have, because the units cancel, I would have meters per hour. Now I need to change it to kilometers. Well, for kilometers, we would multiply that by, we know that 1,000 meters is 1 kilometer, and that's from the conversion chart that I gave you today too. All right, and so if I multiply this, okay, I'd have 542 times 3,600 over, and this would be just 1 times 1,000, so that would just be 1,000. And this would be kilometers per hour, all right? And so when we do this, 542 times 3,600, we get, and then divide by 1,000. Okay, and what I get is 1951.2 kilometers per hour. And here's the problem with this. This is 1, 2, 3, 4, 5 digits of accuracy, 5 digits, yet we only started with 3. So this can only be 3 digits of accuracy, and the precision, and we're going to talk about precision on Thursday, as we go across, this can only go to 3 digits this way. So it's 195. Now, what we're going to do is we're going to look at this, okay? What is this one right here, okay? And this one right here is a 1, which makes this a 5. So this is 1950. So that's 1,950 kilometers per hour. And so this it has only 3 digits of accuracy because our original problem only started with 3 digits of accuracy. So the essence of significant figures is you can only be as accurate as the numbers that you are given. And so since we are only accurate to 3 places here, we can only be accurate in our answer to 3 places. And so that's just a placeholder right there, that's 0, okay? All right, guys, so hopefully this helps out. You're gonna be able to answer these a little bit easier because I know a lot of you guys, the work that you were doing, because you showed me the work when I saw you guys on Zoom, and it was right, okay? You're doing the right work. You just didn't know about these significant figures and some of the units. I should say this, amperes. I spelled it wrong. So amperes, okay, the symbol for that is a capital A. And the reason being, we don't use lowercase a. Lowercase a represents acceleration, okay? And for volts, we use capital V, not lowercase v, because lowercase v stands for velocity. It stands for something different. So these units, it matters, okay? All right, so capital A, all right? I will tell you this, you're never gonna get marked down. Like, you're not gonna be marked incorrect if you either have the wrong units or you forget the units, or if you don't have the right number of significant figures. It just doesn't accept your answer, okay? So you can keep putting it in as many times as you want to until you get it right, but you have to have the right number of significant figures, okay? All right, hopefully this helps you guys out. Let me know, okay? And give me a thumbs up on YouTube or whatever, okay? Just kidding. All right, talk to you later.